Hello everybody and welcome to my channel. Today I have an interesting system of equations which is nonlinear, and perhaps you're wondering how could one solve this problem without getting into too much calculations. So I am sure there are different ways to solve this system of equations, but today I'm going to show you one way, one interesting way, which is basically using cubic equations. And only in this case, because we have some, symmetry in the system. As you can see, x, y, and z are symmetric. If you just replace them with each other, the whole system does not change at all. And also, we don't have weird terms, for example, such as x2 plus y. So, like in every equations, the orders are all the same. If you change this, let's say y3 to y2, then I'm sure this becomes a little bit more difficult. But because we have this symmetry, we can actually make use of some of the nice properties of the cubic equations. So let's say we have as a matter of fact, we're trying to find x, y, z. So one mathematical trick for such systems of equation is that we assume x, y, z are the roots of a cubic equation, okay? And if that is the case, then I have something like, let's take t to be our variable. So t minus x times t minus y times t minus c equals 0. And this is nothing but the same as t3 plus beta 1 t2 plus beta 2 t plus beta 3 equals 0. So if I expand this guy here, I should get a general cubic equation like that. And obviously there's some relationship between x, y, z and beta 1, which we're gonna right now going to find out. So if I expand the first equation here, then what I get is basically t3. Please feel free to verify this, but it's very easy. So I know it by memory because I have done it many times in the past. So we have basically t3 minus x plus y plus z, t2 plus xy plus xz plus y zt minus x, y, z equals 0. So if these guys are the same, then I can say, beta 1 must be minus x plus y plus z. Beta 2 must be xy plus xc plus yz. And beta 3 must be x minus xyz. Okay? So, as I said to you, I wanted to remind you before continuing, you might be wondering, why am I doing all of this computations? So the trick again is to basically assume x, y, z, which we want to find, are the roots of a cubic equation. So if I can solve that cubic equation with these roots, if I can solve that cubic equation, it's like solving this system of equations. You will see in a couple of minutes. So I have these relationships, but I already know that the system of equations tells me x plus y plus z equals to 2a, right? So then I can say, beta 1 is nothing but minus 2a. Beta 2 I still don't know what it is, but I think I can find a way actually to calculate that. Because if I look at the second equation in the system, let's rewrite it again. I have x2 plus y2 plus z2. This is equal to 6a2, but I can use some very well-known algebraic identities, which is basically this one, x plus y plus z to the power of 2 minus 2 times x y plus xc plus yz, okay? But x plus y plus z I already know. This is 2a. And this is, as a matter of fact, beta 2. So then I can say, take these guys to the other side, and I can say, well, beta 2 must be equal to 2a2 divided by minus 2. And as a matter of fact, beta 2 must be minus a to the power of 2. Okay, so I found beta 2. I already also found beta 1 here, and I just need to find beta 3. So, as you can imagine, I already made use of the first and the second equations in the system, and somehow I have to also make use of the third equation, perhaps to find beta 3. Otherwise, it should not work. So let's again pay attention to the general form of this cubic equation here. So we have T3 plus beta 1 T2 plus beta 2T plus beta 3 is equal to 0. And we know x, y, z should be the roots of this equation because that is how we defined it. And it tells me then I can write x3 plus beta 1 x2 plus beta 2x plus beta 3. Sorry, it became weird a little bit. Beta 3 equals 0. This must hold true, and the same for y and z. So y3 plus beta 2, y2 plus beta, sorry, this is beta 1, beta 2y plus beta 3 equals 0, and then also z3 plus beta 1, z2 plus beta 2, z plus beta 3. This must be also 0. If I sum up all of these equations with each other, so you can already see here, this whole expression already is formed. Well, let's do that. So we have x3 plus y3 plus z3, and then I factorize beta 1 times x2 plus y2 plus z2 plus beta 2 times x plus y plus z plus 3 beta 3. This must be 0, but these guys here are basically what we have in the system of equations. So this is 8a3. If you go back to the system, you can see that this is 6a2 and this is 2a, right? I already found beta 1 and beta 2. This was beta 2 and that was beta 1. So I'm just going to replace everything here. I already find beta 3. So then I get 8a3. Beta 1 was minus 2a. So basically minus 2a times 6a2. And beta 2 was minus a2. So basically minus a2 times 2a plus 3 beta 3 must be 0, right? So that gives me 8, 12 minus 4 minus 2, minus 6, a3. Goes to the other side, becomes plus, and then as a matter of fact, then I get beta 3 is equal to 6, a3 divided by 3, which is basically 2a3. This is also beta 3, okay? So now if I go back to my beautiful cubic equation, I already have all the terms. So as a matter of fact, I get T3 plus beta 1, which was minus 2a, T2 plus beta 2, which was minus a2, T plus beta 3, which is basically 2a3. This must be equal to 0. So how can you solve this problem, this cubic equation? Well, if you take a look at this, it's not really difficult to solve this cubic equation because all we need to do is to reorder the terms a little bit. So if I just write T3 minus A2T minus 2a, let's factorize minus 2a times t2. So these guys with this guy, and then the other guys here with each other. So minus 2a times t2 minus a2. So you already see a common term here, common factor, because this is also t times t2 minus a2, right? So this is t2 minus a2 as well. And as a matter of fact, this gives me t2 minus a2 times t minus 2a equals 0. So I already know all the roots. So basically t must be either a, t must be either minus a, and t must be either 2a, right? So these are the values for t. I already also know that x and y and z are the roots to this equation. And by the way, that system of equations is also symmetric. So whatever value x gets and y and z also get, you can basically switch them, and that solution also is correct. In other words, x could be either a, and if x is a, then I have y equals minus a, let's say, and then z equals to 2a. But I can also say x is a and y is 2a, switch basically y and z is minus a. So these are two sets of equations, but there is again more. I can also say x can be minus a, and then y is a, and then z is 2a, or x is minus a, y is 2a, or z is basically a, or another set will be, which is basically the last one, x is 2a and y is a and z is minus a, or x is 2a, y is minus a, and z is a. So that was it. In general, we have 6 sets of answers. I hope you enjoyed this solution, this unique solution, and if yes, please consider to subscribe to my channel. That will help me a lot with my content. And also please give it a thumbs up, and I will see you in the next video.